with that in mind. Today, review 3. Sorry I didn't put my number on here. I should have. A little bit with our trig stuff, just the stuff that we're going to need on the multiple choice part of the final. Find the value of the trig function indicated. Now, one thing that you will have, because you're going to have a help sheet with this, is you will have this part right on there. But you're still going to have to be able to use it. So, if we're doing cosine here, I noticed when I looked that cosine is adjacent and hypotenuse. You're like, okay, but how do I tell what's what? Wherever that little angle measure is drawn in, that is going to be where I kind of figure this out. So I look, the side opposite my right angle, still my hypotenuse. My side that's opposite my angle is still opposite, which means this is going to be adjacent. So I look and I say, hey, do I already have the sides that I need? If I do, because cosine's adjacent over hypotenuse, I just write it down and go about my business. Okay? Sometimes I may get that fortunate, sometimes, but not every time. So for instance then, let's say I don't get that fortunate sometime. So I've got my angle here, and I'm like, okay, so I got my hypotenuse, I got my opposite, I've got my adjacent. Now, if it was cosine again, perfect, but it's not. This time with tangent, it's opposite and adjacent. Well, I've got the adjacent part, I need to figure out the opposite part. How can I figure that out? Ooh, now I like the way you're thinking, except that would help me get an angle. I'm trying to figure out this side. I don't need any fancy trig functions for this. We're going to go old school, back to probably geometry, maybe even algebra 1. If you've got a right triangle and you know 2 of the sides, what formula, or maybe you should say, what theorem should I use? Pythagorean, okay? Which again is my 2 sides squared, we'll just call this x, equals my hypotenuse squared, or my long side. And so I'd work through this, and I'd get it punched into the calculator. And I'd solve this just like I do any other. So I'd minus my 81 over and take my square root and get my opposite. Okay, so sometimes there may be a little bit of work involved here. So once I get that situated, now I can go back and say, okay, so opposite over adjacent is 12 over 9, but again, if I can reduce, bless you, I want to make sure that I do that. Okay. So it's just kind of working through some of those things. So that's how I deal with just finding the value of the trig function. Okay. Positive and negative coterminal angles. Again, coterminal. Plus or minus my 360 degrees to be able to get there. So, and I got to find one for each. So normally, I'm just going to bust out my calculator. And I'll be like, all right, negative 144 plus 360. Okay, and I can get that one. And it's a positive angle. I mean, if it's going to be a positive coterminal, it has to be positive. I hope that's common sense. And then minus 360, and I get a negative. Now, sometime if you do this, and let's say you're trying to get a negative, and you minus your 360, and it doesn't get to a negative value, you just got to keep doing that. You got to keep minusing or plusing the 360 until you get there. And then the same thing working here with my plus. Okay, so if I do my 195 plus 360, fives are wild here, and I just work that through. And again, the coterminal help will be there on your help sheet, so it's really not going to be that big of a deal. Okay. Now, there's a difference, though, and this is where people tend to get confused on a final or any kind of test or quiz with this. Coterminal is different from reference. when we get to a reference angle, what we're trying to do is get back to the closest x-axis. So to me, that's going to be degree measures. So that could be 0, that could be 180, that could be 360 degrees. Whichever one of these values is closest to this, I'm just going to see how far it is away. And the other thing I want to make note of here is that my reference angle is always, always, always going to be positive. Even if it's a negative angle, even if you went backwards to get there, doesn't matter, it's still going to be a positive value. So when I look at the first one at 225, I go, okay, which one of these numbers is closest to 225? 180 is. So I just do 225 minus 180, and whatever that is going to be my reference angle. Now, the one I have to be careful on, though, when I'm doing these, and I'm glad I've got one of these on here, is when it's a negative. Okay? Because basically, here's what I'm doing. I don't want to do 165 minus 180, because you're like, well, 180 is the closest one, so I'm just going to minus it, right? And I'd go on in negative 165 minus 180, and you end up with some big old crazy number like 345. It's never going to be a really big number. It's going to be kind of small. So really what you want to do here is look at that like it's 165. Okay? 180 again to be the closest. 180 minus 165 would be 15, and then I'm good. Okay? So when you see a negative, you're almost going to kind of act like the negative's not even there, because we're just trying to find a little bit of a distance. Conversions. Convert degree measures to radians and radian measures to degrees. Okay, when we're in degrees and we want to get to radians, we want pi involved. So we do pi over 180. Now that doesn't mean I just get to leave it like this. Okay, I don't want to put the pi in there. I don't want to put 3.14 and get some decimally answer. Okay, I'm looking for an angle measure. So what I'm going to do is I'm going to take the parts that aren't pi, negative 30 divided by 180, math, enter, and I'm going to write it this way. And if you want to put the 1 in there and make it negative 1 pi over 6, that's okay. But that's what I'm looking for there. So degrees to radians, we want the pi up top. And then when we want it the opposite, when we want to go from radians to degrees, we kind of do the exact opposite. We do 180 over pi because we want the pi's to go away. And then I just do 7 times 180 and divide by the 6. And that'll give me my degree measure. So that's basically all that we're looking for there. It's just getting those situated that way. Okay, so hopefully that's kind of starting to click a bell, because again, that didn't ring a bell. Click a bell. Oh boy. Click a bell. But hopefully this wasn't that long ago, so hopefully it's kind of refreshing in your mind here pretty easy. Okay, use the given point to find the value of the trig function. Okay, whenever we get these with a point, we always are going to make a triangle back down to the x-axis. And let me zoom in here some, make this a little easier to see once we, oh boy, once we get back into focus here. You know, sometimes it's fuzzy in your head, kind of like this. So when I get to this point, there we go. I'm going to take that coordinate point, and remember, coordinates are just an x and a y value. So this is telling me how long this side is. The y value, since y goes up and down, is telling me how long this side is. And the angle that we're using is always the one that's connected to the origin, always the one that's closest to 0. So when I go to label my sides then, because I'm trying to find sine, I'm like, what do I have already? Well, let's see. I've got hypotenuse, an opposite, and adjacent. But I know for sine, I need opposite and hypotenuse. And do I have both of those values already? I don't. I know what opposite is. That's 2. But like we did up above in number 2, I got to figure out what the hypotenuse is. So I take my 2 sides squares that I have, and that's going to help me figure out what my hypotenuse is going to be. Now again, you can do it in the calculator, or if you're just kind of doing it on your own, 2 squared is 4. When you square a square root, they basically are inverses, so they just cancel out. And you're like, oh, that's kind of nice. 9 is x squared, so x is going to be 3. So my hypotenuse is 3. I put that in, and I've got my sine value. So you'll notice there's going to be a little bit of work involved here, a little bit, but it's not going to be anything that's too terribly awful. Okay? And then 10, just to kind of reinforce it one more time. Get my little mini triangle drawn in here. And I've got my x and y values. So x is on my x-axis, y goes the y direction. Now this time, again, don't always assume that you're going to have to find that missing side. Sometimes you may not have to. Like here, tangent, SOHCAHTOA, is opposite over adjacent. If this is my angle, here's my opposite, here's my adjacent. I'm missing the hypotenuse, but I don't need it this time. I'm just doing opposite over adjacent, and then simplifying the fraction that's left. Okay, so if I need the extra side, I can use the Pythagorean theorem. If I don't need the extra side, I just take the values that are there. That's the nice thing about having a picture where I can actually draw that a bit and see how that works. And then finally, and I'll just stay zoomed in since we're already zoomed in. Using radians, find the amplitude and period of each function. Now remember, my amplitude is just the value in front of my function, but it's always positive. So if one of these would have been negative, I don't put the amplitude as negative because that's never going to be the case. So here my amplitude would be 9. But don't just write the period as 2. The period is 2 pi divided by b. 2 pi divided by whatever this number is. So in this case, that would be 2 pi divided by 2, or just pi. And then for 12, ooh, I saved a doozy for the last. Okay. My amplitude, no big deal. Now, this is where this gets a little more interesting. We talked about this before when we were dealing with these. This pi over 4, let me just rewrite this whole thing for a second here. Okay, it's like having a b value that's a fraction. My b value is not 4, because that doesn't say 4 theta, it says theta over 4. So, since my b value is 1/4, I like to think about this horizontally instead because it just makes me think a little bit better. So if I had 2 pi divided by 1/4, remember when we divide by a fraction, it's the same as multiplying by its inverse, or flipping it. And when I flip that, I end up with a bigger period than I'm used to. Because if you divide something by a fraction, the value gets larger. Okay? So those are the types of things we're going to tackle today to make sure we're ready for the final. Again, tomorrow we tackle probability again. And then Monday we just go full-fledged, little of everything, trying to see where we're at and have you ready and ready to go by next week.